Okay, let's crank through another video here. Let's talk a little bit about how to make a waffle plot in D3. So we're going to use a data set uh, that I've sort of worked with a little bit. It's from the World Income Inequality Database, and I have manipulated it a little bit, managed it, transformed it a little bit to get it ready to work with the creation of a waffle plot. Essentially, we get it down to some percentages that have been uncounted. And so we've got 100 rows and we've got quintiles of information about income inequality. So let's look at what the final plot looks like. So world income inequality, quintiles of income in the Americas. Q1 represents the poorest 20% of individuals averaged over the countries in the Americas, and Q5, for example, is the wealthiest. And so you can see the disproportionate amount of wealth in Q5 relative to Q1, and there's some interactive features here. So you hover over the square, and you can see exactly how much is what percentage of the total income is represented by the top 20% of the population versus the bottom 20%. So the way the data are structured before we even get to it is that we have a row representing a percentage point for 100 total percentage points. These are obviously rounded. And then all we need to do is provide some instructions about the locations of the squares. So let's look at what the data actually look like. Let's inspect and let's look really quickly in the console at the data. There are 100 total rows in the array. Each object is nothing more than which category that particular row belongs to. So it's just one categorical variable, basically, one string. And it's called quintile in this case. So what we're going to do, we don't actually need data for X and Y that is representative of the data. All we need is an X and Y for the location of the squares. Okay, so that's what we're going to do here. All right, so D3 CSV, we're going to import the data. The data are called America's Waffle X1 CSV. And instead of the await async version, we're going to use the then and then a function. And so this wraps all the way around everything, because we're working in this asynchronous sort of promise universe. And then I just, again, usually we'll have a console log just to take a quick look at the data. We're going to set up some groups, call them quintiles. I will randomly use things like Z for variables, constants, objects, and things that I make to differ from what sort of a typical programming language would call them. So set up some groups by quintiles. Then we're going to set up margins, width, and height. Okay. These can be, in prior examples, I've used inner width, inner height, setting up something that's square in this case. So I picked some numbers, right? It doesn't have to be these numbers. But I want it to be an approximately square space because the final plot is going to be a square. Okay, so then we need to set a constant for the number of squares and a little bit of padding. And all you need to know with respect to this line is that we're doing a little bit of math, and some of this is sort of arbitrary and it's based on the final look of the plot. That's going to tell us how large each square is going to end up being. So if we play with this math, the size of these individual squares is going to be a little bit different. All right, but I like sort of the balance that you get there between the white space and the waffles right now, the waffle squares. So In assuming that you're using a waffle that is approximately 100 percentage points, which is not always the case, you might do something like this where you use square root to make sure make sure you include some function of padding so that you get down to a size of squares that's at least a little bit less than sort of the square root of this total area of the square, the padded square. Okay. So creating a constant that's going to set up the size for each individual square. Set up a div here and set up an ID for plot 1. So inside for our SVG, we're going to select plot 1 ID and we're going to append our SVG to it. And then we're going to set up our width and our height. Now you could do all of this inside your margin stuff above, and the width and the height above. You could do some of that. Anyway, it's kind of an inverted logic from the way we did it before with the scatter plot. Append G, and then we're going to do a transformation to make sure we get our margins right. Okay, so we're just moving things just a little bit. Okay, and then we're going to add our squares group. And then we're going to go ahead and set up highlight functions for the interactive feature. And basically what all this is saying, so we set up a function and we say given an event, which is going to be mouse over later and then mouse out or leave later. For the datum, we're going to make all the rectangles that we see, the squares, 25% opacity, so we're going to make them pretty transparent, except for, and this little string here says, for the one that I'm actually hovering over, for the group that I'm hovering over, for the rect group that I'm hovering over. Make it a transparency, make it completely opaque, make it not transparent at all, full color. Otherwise, for the no highlight, we're going to just make everything, so once we leave, it's going to go back to a full opacity or full no transparency, right? So full color when we're not highlighting anything, but if we highlight something, we're going to highlight that group and sort of make the others transparent. So we're actually focusing on a particular group. Okay, so now we are going to set a scale. So here normally we would set up a scale for X and Y for the Cartesian coordinate plane because that's exactly what we're working in. However, we don't actually have an X variable in our data that needs to be translated, needs to be mapped to pixel space as such. We don't have a Y variable that needs to be translated to the pixel space. All we need is locations in the pixel space. So I'm actually only going to set a color scale here. Scale ordinal for categorical. And our domain is the data space. We could have called this from the actual we could have called this from the actual data, but instead what we're just going to do, because there are only 5 categories, we're just going to write it hard code in a little vector here, just like this. And then to the pixel space, that's going to be our actual color values, and we're going to hard code those in hex codes as well. So data space, pixel space, our groups, and the colors that are assigned to each group. That's it. And again, we don't need an X and a Y. Okay. Let's pause there, and we'll pick up in the next video.